Okay, let's try to solve this question real quick. So we need to solve for the limit of x cos x minus tangent to x divided by sec to x as our x approaches 0. So if you try to substitute 0 into this equation, you'll get 0 over 0. Okay, you cannot solve for 0 over 0. Okay, you'll get 0 over 0 if you try to substitute it directly, so you cannot solve for that. Then we need to evaluate this equation. So the first step is to turn our tangent here into its sine and cos equivalent. So let me write it here. Tangent x equals to sine x over cos x. So if you have got tangent to x, it will be sine to x over cos to x. So let's just change that tangent into its sine and cos equivalent. Okay, minus sine 2x divided by cos 2x over sec 2x. Now what you need to do is to split this fraction into two separate parts. So the first part will be limit of x approaches 0 for x cos x over sec 2x minus with the limit as x approaches 0 for sine 2x over cos 2x multiply with sec 2 multiply with x. Now let's solve for the first part right here. As you can see, you have x at the numerator and denominator part, means you can cancel them out. So what you are left with is this cos x over sec 2. So can you substitute this 0 directly into this x, okay, in order to solve for the limit? Yes. Okay, because cos 0 is equivalent to 1. So if we solve for the limit of this first part right here, okay, cos 0 will become 1. So the solution for the first part will be 1 over 2. Then let's move on to the second part. We have got sine 2x over cos 2x multiply with sec 2 multiply with x. And the next thing that you need to know regarding the limit of our trigonometric identities are their special case. So we are going to apply a special case for sine rule, okay, which looks like this. Okay, if we have an equation of sine x over x, as our x approaches 0, it will become 1. So the same goes if we have sine 2x over 2x, it will also become 1. So that is the special case for sine. So special case for sine. So now let's try to turn our equation into the special case of sine. Since we have got everything below our sine 2x here as the denominator, and we can leave this x as its denominator and put the rest of it elsewhere, right? Since this is just a normal multiplication process, so we can copy this sine 2x and let's just pick this x and bring it below that sine 2x. Then we just multiply it with the rest of the equation. Multiply with 1 over cos 2x multiply with sec 2. Now we have two separate parts. Okay, the first part right here is sine, and the second part is 1 over cos. So our next job is to turn this into its special pattern, which is the 2x as the numerator and denominator. So how do we turn this denominator into 2x? Simply by multiplying both part by 2. So you need to multiply the numerator with 2 and denominator with 2. So what you will get is the limit as x approaches 0, 2 sine 2x over 2x multiply with, and we can apply the same limit property for multiplication process. So this limit will apply to both parts right here. So we have got another limit as x approaches 0 for our second part, cos 2x multiply with third 2. So it is obvious now we have turned our first part right here to become its special pattern. Then we can cancel them out and it is equivalent to 1. So now you have got limit of x approaches 0 to multiply with the limit of x approaches 0 for 1 over cos 2x multiply with third 2. Now we can solve this part right here easily, because the limit of any constant as x approaches any constant will become the constant itself. So the limit of 2 as x approaches 0 will become 2. So 1 over sec 2 minus 2. And then let's solve for the second limit right here, for the second part. Okay, we can still apply that cos 0 equal to 1 to this part. So if we solve for the limit, substitute 0 into this x, so cos 2 multiplied with 0 will become cos 0, and everything right here will become 1. So 1. Then we are left with 1 over sec 2. Now let's multiply that 2 with 1 over sec 2. Then we get 2 over sec 2. And finally, you just need to minus this part with the second part right here. So 1 over sec 2 minus 2 over sec 2, you get negative 1 over sec 2, and that is your answer.